All right, so got a couple friends that sent me some parts asking for us to make some axles for their car, for a series of cars, I should say, 1 and 2G Mitsubishi Eclipse. Wanted to go over some slight details of the build, and like what most can see, and I'm pretty sure second gen axles are different. I'm actually waiting for a pair of them, or a set of them I should say, to show up for the all-wheel drive and front-wheel drive versions of your car. This is a 1G, I believe it would be your right front, so your passenger axle. Standard design, it's pretty durable as an OEM axle, but there's a lot of room for improvement. As you see here, we have a standard 100mm Empi Cv Joint. It's the basis of performance for a lot of the axles that we make here. I'm not sure if you can see that serial number there. This is how we make them. Essentially building a base Porsche axle with modified inner and outer flanges to allow the capability of bolting to any platform. In this case, the first thing we do is we will take the overall compressed axle diameter. So compressed meaning completely pressed in to where it has no more room to move. So completely compressed. We will take that axle measurement from inner to outer, and we will calculate that into the overall design of the axle, less or minus these joints here, the inner and outer joint, to determine a overall shaft length. Because the Porsche interface is completely different than what you would have out of a standard ball and cage design that these poor axles have with them. So in this case, we chose Porsche Axles as a grassroots approach to high performance because of the angularity. So these things, pretty easy to take apart. Literally, you will compress the center and you'll twist them out. This is the basis of high performance that Porsche offers. Porsche and Volkswagen, I should say. And in these cases, the standard ball and cage can easily be disassembled to allow for easy cleaning, practical maintenance, fatigue and damage caused from standard runs and endurance. It could be a whole list of things, a myriad of things. But the inner race comes out exactly the same way as the others. You can use a whole list of tools here to make the job easier for yourself. In this case, I just like to disassemble them. This way, I can show you guys a little bit better on how they're made, why they're made the way they are, and essentially, sorry, I'm dropping ball bearings everywhere, and essentially go over the characteristics of why we build our axles the way we do. So it's no secret, we have been kind of tasked here to build axles for a lot of different vehicle make and models here recently, for which we've had to learn on the fly and build a lot of different designs to support this moving forward. In this case, we will also, besides just looking at the compressed length of the axle, we will also look at the placement. Now, a standard joint like this on the outer, not a good idea. In most cases, the issue would be that you need to have a fixed point of articulation. A fixed point meaning standard Porsche axles are inner and outer free floating because these joints are designed for the rear of the car. In this case, depending on how your suspension geometry reacts to the road, how everything travels, you will either use this or you will use this style cup ball and cage design versus a standard race ball and cage that Volkswagen and Porsche offer. In this case, since this is going to be a front axle, we will no longer entertain the idea of utilizing this for the outer. which would be the side where your splines are to go into your hub on this side here. But for the inner, it leaves us a lot of room to allow for additional angularity where the axle just wouldn't allow prior. So the determination on size using a joint is based on the interior design of your transverse all-wheel drive system, front-wheel drive system, whatever. Space available. So we're looking at space available. Space available, if you look at it, standard 90 millimeter, it's probably about twice. Move this over a little bit. Probably about 30% bigger than your OEM. So this right now is plenty strong. However, the installation area also is affected by this overall diameter, because whether we go up a joint size to one that's bigger, see the size difference here, versus one that's smaller, 90 here, will determine how much clearance that we have within the hub area, passing by the shocks or whatever other sensors and other tie rod ends, things like that, that may be in that area. So shaft diameter is also important, but more or less for performance. How much power can I put through this axle? So there's a lot of different characteristics that come into the requirement for these. And I can tell you now, the bigger circle that you have, meaning the larger the diameter, the more geometry that you can have. And with that, as the geometry, or excuse me, as the diameter of the circle changes, so does the width. So that is also important, because that controls how far that the bearing race can turn inside of here before you lose continuity with your outer casing and your ball bearings end up becoming damaged or dislodging themselves from the rest of the joint. So looking at things here, for our performance axles, a standard 90 millimeter joint can only see about 17 to 18 degrees. So you guys know a standard Honda axle, and this is Mitsubishi, but a standard Honda axle can only see, and this would be the inner joint, can only see about 15 to 18 degrees of suspension articulation before it starts to bind, and bind causes vibration. Vibration is what breaks shit. So in this case, a 90 wouldn't be a good option because it doesn't leave much room more than factory for angularity and for suspension travel. So with that, we move to a 100. Your 100, typically 22 to 25 degrees of angularity before bind. That exceeds the angularity of OEM and allows you much more flex travel and overall a lot stronger joint for the inner. But if you look at the inner, we're about 42%, maybe about 42% larger than factory. That's going to be an issue trying to stuff this fat kid in the area where this small diameter comes in. So with that, that affects the length of the flange that will bolt here, meaning the taper of the cone going out, similar to this, as we attempt to push the joint farther away from the transmission, or in this case, the half shaft or transmission, allowing for clearance to be generated, which will also shorten the shaft length and ultimately affect geometry. So using a 100 mil in the place of where something like a 90 would be, if you have adequate space, would be great. But that's where the engineering and troubleshooting comes in. In this case, designing a flange that will give us the angularity to push farther away from the transmission to allow for the clearance to happen so that we can place the joint, and then your boot and things of that nature. For the inner, it's fine. For the outer, it leaves more of a problem, because now, whether it's using front and rear, you are also competing with the shock body forks or in this case, the shock body, depending on whether it's front or rear. And you're also competing with any other sensors, height sensors, any of that equipment, and again, sway bars. So when we design these things, we take this approach. Ultimately, the diameter of the shaft depends on the joint size that we use. Now, a standard 190 millimeter use the same spline, the same diameter, the same everything. So these can be used to make a hybrid axle, no problem. But where space is always going to be the concern with building a high performance axle in a small form factor, you have to look at the flange design will determine the flange design will determine the length of the shaft and how far we need to push this side from the transmission and this side from the hub to gain clearance. So that could shorten this to where you could end up with a CV axle shaft that's this long. It really just depends. This whole technique and this design was brought in about by grassroots racers way back before I was ever even a faint memory in building axles or even being alive. So this grassroots approach to engineering technology provides the capability for a lot of modularity. And by modularity, for those of you who are not nerd-centric, I should say, by modularity meaning a multi-purposed, multifunctional axle set. So like if this was a Porsche axle here, and I designed it to where it was modular in design, I could change this inner and outer flange to go with anything, and it won't matter. There's plenty of other cars out that share similar characteristics in length and requirement of spline, but because our flanges are designed with the same height in most cases, we can convert, say, from a CRV inner to a wagon inner, and you'll never have to change your differential axle combo in the rear. You just run the same axles and switch out your flange. Oh, I'm upgrading from a CRV diff to a wagon diff. Boom, here you go. Or in this case, I'm doing a 1G swap to a 2G trans, whatever. Whether they're the same or not on the inner splines, you can swap it out because the engine sits in the same general location. So this helps in procuring high performance axles, and also allows for additional capability in boot design, in cooling, in clearances, because there's so many different fitment parts out there for Porsche that you can essentially run different boot designs that all allow for more oil, less oil, more clearance, meaning in diameter here, because the flange bolts here and the boot starts a little lower, making a little bit more clearance to shock bodies, a little bit more clearance to other sensors, height sensors, things of that nature. So here, and using these axles as a basis to design the new ones from allows us to not only capture the spline data on both sides, but it also allows us to capture other characteristics and see other clearance issues that we may have. That, coupled with information from the initial customer who's wanting these axles, we will ask for pictures of the bottom of the car and the areas where these axles will be installed, maybe even potentially asks for measurements. I need to get measurements on how far the boot gets with this design, how far the boot goes out and extends from the hub relative to where your shock would be or your sensor would be. That helps us predict get a better understanding on how far we can build the joint and push the joint away from any eccentric area where we would need to taper the flange design out to allow for better fitment. So once we have that data, we send that out, we make a 3D printed mold. We will take said 3D printed mold and try to match the spline data as exact as we can, and we send it off to our manufacturer. We have 4 manufacturers that make axle parts for us, and out of those, we utilize their express expertise, I would say, or their express knowledge of these splines that we create here. Now, there's a lot of math. You look at these, like, oh, it's just a spline, it's no big deal. Dude, there is a lot that goes into designing a spline and even designing threads that most people don't even realize. And though it's crazy because SolidWorks does a lot of that itself, it's not always as accurate as it says when you're kicking G-code out, asking it to cut this shape based on this 3D dimensional data that I got from a SolidWorks library file of a M12, whatever. So, hey, I want you to cut me an M12 thread. Like, M12 thread may come out in SolidWorks, but it's not gonna match the nut. So it's a match set. The data requires massaging, and it requires a lot of small corrections to it before it is 100% ready to be manufactured. So the axles that we have now took us 8 months to develop and push into production after we had our first, I think it was 8 sets out for testing. We have configured axles for Ridgeline, Element, CRV, all-wheel drive conversions for various different designs, standard trailing arm, which will be like standard CRV Element with whatever inner CRV wagon Element cross tour HRV differential you want to run. And then we started making the limited slip differentials based on the samples that we had here also. These are all OEM samples. We took OEM samples and said, I like the LSD designs that we have out, but we want a little bit more capability of adding a ramp engagement clutch on the inside and a progressive cam profile that allows us to set preloads in the differential without affecting anything else on how fast or how hard the LSD engages and how long it takes for it to lock. Looking at the dynamics of this should make a bulletproof transmission gear set. Now, it doesn't mean that it's indestructible. Your drivetrain will be very strong with an aftermarket axle. Not sure about insane shafts, but these leave quite a bit of room to move in their respective places. But the joint design is the most important part of this because that decides where your axle starts to articulate, and also helps control how soon your bearings start to wear. And remember, the farther away your pivot point is from the angular surface, the more wear that it potentially creates. As long as your axles are balanced and everything is within a spec, allowing for good operation at the RPM that you're spinning these at, you should be fine. But remember, the farther away your axle end gets from the angular area, the more vibration you could essentially induce to your system by having an axle that's out of balance. There's a lot of different ways. Like I've seen people use these stick-on weights or whatever, adhesive weights on these things. I don't know why they do it. Our axles are literally balanced to 20,000 RPM, and we never expect any of you guys to ever turn 20,000 RPM unless you decide to glue or paste or weld or some shit, a turbine or something to the back of your car and use that as a power plant instead. But again, why the hell would you need axles? So in this case, keeping it from the mad scientist talk, we are taking a Mitsubishi axle here and we will be converting it over into a Porsche style. This is again a 1G front axle from an all-wheel drive vehicle. We will be taking this and designing the flanges based on the dimensional data that we are able to get from the axle and the dimensional data that we are able to obtain from the hub area and clearance to the transmission on the right-hand passenger side. For this and for the opposite axle, we are looking into making the axle with the clearance to support the half shaft. As you know, the half shaft sits behind the engine, up against the engine block. It bolts to the back and it leaves potential clearance issues, as it travels by your crank pulley and the side of the motor where your oil pump will sit, by the transfer case. All these things have to be considered. So that will also change the space available for the diameter of this shaft, because we are also looking at sensors on the back of the motor. We would also have to consider as a deterrent from larger diameters. But as we've seen, it looks like we can fit a 33 millimeter shaft back there. Now, what that translates into you is, this factory axle here, I believe is a 24 and some change millimeter diameter. You Mitsubishi kids will be getting 30 millimeter diameter CV axle shafts. That is the base diameter here, and on this 90, literally, we are looking at increasing yours significantly, making the diameter of the shaft larger to allow you to hold more power, exceeding 1,000 horsepower without ever having to buy another set of axles in your life. Literally, with the amount of maintenance capability that these axles provide, you can essentially run your car as hard as you want to. If you ever have any issues with needing to rebuild your axles, you can literally take this to an off-road shop and say, hey, I need another Empi 90 millimeter joint, and you can essentially pick up the consumable parts, I should say, consumable parts, so that we are not a single point failure and limit your scope and capability of performing maintenance to your own car. The other shops out that were doing Porsche style axles want to make sure that you can only go through them to buy replacement parts, which makes them a one-trick pony, when it comes to serving your needs to keep your car on the road. I want you guys to be able to go anywhere and everywhere to buy parts to rebuild or replace your axles, with the exception of the shaft and the inner and outer flanges. Those are lifetime warranty. Since they are not consumable parts and they come through us, we will warranty those for life. So if you decide that you want to go and take your car out and run it to its maximum potential, and you break something, which will more than likely be a transmission, not an axle, but if you decide to run it and break something, we will lifetime warranty these parts and ensure that we can keep you on the road and moving and operating your car with as much with as little problem as possible. But that does increase your capability of worry-free driving, worry-free operation for street and strip, or just strip. These axles can be made in a custom size diameter of your choosing. So if you have any axle diameter designs or ideas or requests, they can be made to your spec. The only thing we say is that we will more than likely need you to purchase at least 5 sets. Because making them an axle set custom for your specific vehicle that no one else will ever use is going to be pricey by itself. But even more so in manufacturing, because it doesn't follow a standard design that we will use anywhere else. So we can't share the manufacturing costs with anyone else unless there's other people who want that same design. In this case, this customer asked us for a custom set of axles for which we will use a 90 millimeter inner, more than likely, and a 100 millimeter outer, so that we can give him some space and clearance, but we will make the flange to where it tapers out to give him clearance to the hub, clearance to the knuckle, the back where the shock goes, and will give us the room to pass by the transfer case and to pass by the sensors on the back of the motor and coming off of your half shaft. This is a pretty unique process here, but we will go over some of the designs here later as we continue to innovate and design these high performance products for the rest of you. As for everyone else, send me a project. Really interested in the dynamics and characteristics of suspension work, and love making high performance drivetrain parts. Most of the time, it will take anywhere between 30 to 60 days to make a working prototype, and that is based on quantity, demand, and also availability of our 14 CNC machines that our partners have in manufacturing. So again, we only use Empi joints. The majority of our stuff is all 4130 or 4340, depending on the requirement. High performance axles, like drag race axles, we typically only use 4340. We will use either solid or gun drilled 300M for the shafts, and your flanges will be 4340 billet steel as well. So CNC'd from a full solid block of billet, and then heat treated. Typically the shafts will have a 45 HRC heat treatment, or as close to it as possible without going over, which allows us to add additional strength but keep the elasticity of the 300M so that it stores that kinetic energy and releases it when you are no longer requiring it off the gas pedal and the suspension is at rest. In this case too, the 4340 is pretty hard metal, receiving its a much higher HRC of heat treatment. We really are more concerned with the material that is used than just the heat treatment alone, because that gives us a better basis for high performance. 4340 was a smart idea. EMPI already made them, so we just went ahead and utilized consumable parts that are already on the market to provide an axle set that you can use for an everyday, all-day race vehicle, street vehicle, or whatever it may be. Rear axles are 1600, fronts are 1800, but come with a half shaft and the bearing hanger for the half shaft. We can assemble, or you can assemble. We would prefer to assemble them here, which makes things a little easier for you as a consumer because you get something that's ready to install right away. However, we are still learning the dynamics of using rubberized coated bearings, or even in this case, bushings to support the half shaft, utilizing a billet bearing hanger itself. So studying quite a bit. There's a mold process that goes along with that, and because we are not using a mold, we are actually using snap rings. It makes for a rougher engagement and more feel of the road when you're driving with this solid half shaft bearing hanger installed. So looking at correcting some of those and making some changes here, but we are continuing to strive forward. AKD's paving the way, regardless of what's going on outside the scope of our product design or development. We maintain vigilance and continue to move forward, striving for the best possible technology we could ever provide you for your race vehicle. If you guys have any questions at all, you guys know how to get in contact with me. My phone number is listed on my Instagram. You can always reach out, or even just drop us a live, or go drop a DM with any questions. But we are 100% open and active and still moving forward like a freight train. There's a lot of products coming. We have front LSDs for B, K, and H, both all-wheel drive and front-wheel drive, that will be dropping soon. Some new billet shift forks, and some new ring and pinions, along with new input and counter shafts with custom gear ratios for your all-wheel drive transmission. Even looking into a sequential shifter and shift forks for the H all-wheel drive guys who are in need of something better than the Gear X traditional trash. So we continue to strive forward to make changes here to better serve your needs. If you guys have any questions, please reach out to us. Thanks a lot. You guys have a good day.